Good afternoon, everyone. Halfway through the week. I hope you enjoyed your lunch break. Welcome to day 3 of RIA's Unlocking Innovation event on a lightweight and low-cost railway. Unlocking Innovation events are the result of a collaboration between RIA, the Railway Industry Association, Network Rail, and the UK Rail Research and Innovation Network, UCRIN. My name's Sam Bemmont, for those of you who don't know me, and I'm one of the Technical and Innovation Managers here at RIA. I'm chairing today's event from my spare bedroom in a cold and very wet outside Tier 3 Loughborough. So today we're going to talk predominantly about the Coventry Shuttle Vehicle Light Rail programme, as well as the possibilities around the reopening of some closed lines. We have some great presenters lined up on interesting topics from organisations including WNG and the DFT. These will be followed by some 5-minute presentations designed to share some really great ideas so that everyone taking part gets a wider view of what's going on and who is doing what. And then to close the day, we'll finish up with a panel Q&A with all of our speakers. You can send in questions throughout the talks by using the question facility on your screen, and I'll be picking the common themes and best questions to put to the panel. The formal webinar should finish at about 3:30. But we then have an optional 30-minute networking session on Zoom for anyone who would like to join in. The link to Zoom was circulated in the invitation to the webinar, and hopefully one of my colleagues will drop that in the messages just now. So the link's there for you. Just a point of note, if you try and join that link before we open the room, Zoom will ask you for a password. It won't let you in. So please do stay on here until we close the webinar. So without further ado, let's hear from our very first speaker then. James Meredith from WNG, Warwick Manufacturing Group, who's going to give us an update on the Coventry Very Light Rail programme to date. So if you could pop your camera on for us, James, over to you.
Lovely. I hope you can see me. Can you see me okay? Yes, I presume so.
Yes,
welcome. Yeah, okay, great. Welcome everyone. So again, yeah, my name is James Meredith. I'm from Warwick Manufacturing Group, a department within the University of Warwick. I'm the project manager for Very Light Rail at WMG, and today I'm talking to you about the Coventry Very Light Rail vehicle. So let's just make sure I can operate everything properly. Okay, good. So basically, I've already said WMG is a department within the University of Warwick. The top right picture is sort of a few of our buildings. We've got 9 or so buildings on the campus. Do research on all sorts of things: intelligent vehicles, digital, organizational transformation, materials and manufacturing, energy, electrification, all sorts of sort of high-tech and manufacturing related items of research. Our work on Very Light Rail started sort of 5-6 years ago, and we've got 2 big Very Light Rail projects at the moment, and I'm giving this intro purely to eliminate any confusion, I suppose, because one of the projects is the Coventry Very Light Rail vehicle, which is sort of a principally designed to be a sort of small shuttle type vehicle, tram replacement for medium-sized cities. And this is very much Coventry City Council funding this directly. We've partnered with Transport Design International to deliver this vehicle. We're also working with Ingerop on another project, which is the low-cost Trackform, which go together to essentially deliver this very low-cost transport system for Coventry. The Revolution Very Light Rail vehicle, just as a separate thing, essentially is a consortium project with RSSB funding and Evershot Rail funding, and that principally is just a lightweight branch line rail car with a hybrid powertrain, and WMG have been involved in the hybrid powertrain and batteries for that project. So today I'm specifically focusing on the Coventry Very Light Rail project. So we started off probably around 2017 with the Coventry vehicle. We've been working with Transport Design International right from the start of this project. And I'll take this opportunity at the beginning just to thank them, because obviously we couldn't have done it really without them. So it's been really good to have them on board. We basically started off with some fairly all sorts of crazy ideas for what the shuttle might look like, and came up with a sort of concept which the council bought into. And ever since then, we've really been focusing on trying to deliver something. The clear direction at the beginning of the project was essentially a desire for a small shuttle vehicle, short headways, 3 to 5 minutes, with no timetable, very much an electric, zero emission vehicle, and cost and low mass certainly were a key focus for us. So that's the sort of brief summary of where we started. We've got a rendering, the bottom right, of which was the sort of the approved look and feel of the final vehicle. And I hope you'll agree that essentially as we've progressed, we've ended up with a vehicle that looks very similar to that. Our current status in terms of the build is that amazingly, despite COVID-19, we've actually managed to continue. The supply chain have done their very best to keep supplying parts and such like. And just the pictures you see here were taken a couple of weeks ago at the build site, which is in Coventry, NP Aerospace, which has been, it's been a great achievement to get to where we are. You'll notice, I suppose, that from the pictures, it's sort of a sort of skeleton you see there. And the build strategy has been very much, we build the skeleton, then we put all the interior in, and then we put the wiring and the external panels on it. So it's not necessarily built in a conventional fashion, but nevertheless, we're making very good progress, and we hope to be on track in around February 2021 at Dudley. So just what I'm going to talk about today in a bit more detail. First of all, the UK content, it's designed and built in the UK, but there's still plenty of opportunities for future vehicles. The fact that it's a zero emission vehicle, a bit of detail on the battery, how we charge the vehicle, and a little bit on the construction of the vehicle itself. We do have what we consider to be an innovative bogie. It is subject to a patent application, and as such, I won't be giving any real detail about that. But we will be talking about the low-cost Trackform, or Chris will be talking after me essentially about the low-cost Trackform, so I won't say anything about it. I'll just focus on the vehicle. In terms of the UK focus, we think, certainly in combination with TDI and everyone else in the supply chain, we've achieved essentially over 70% by value in terms of the UK content for the vehicle, which we're really impressed with. Actually, it's been, a great achievement to do that. And if we look at the next slide, this sort of indicates how, there's a bit of a cluster around the Midlands, but also around the UK as well for many of the suppliers we've had on board. And if you look around the outside of this slide, you'll see some of the international elements of the project. So Sweden, bogie, battery, control system, Switzerland, charging, China, the HVAC system, heating and ventilation, Slovakia was where the chassis was made. So all of these things really have come into the UK, and actually for future vehicles will be a great opportunity for the UK to pick up some of these elements. In terms of a bit more detail around the battery, I apologise for the graphs and such like, but just wanted to indicate a few things. So zero emissions and battery power give us some really good advantages for the overall cost of the system. We don't need overhead line equipment, which is a big saving in itself, and we don't have any stray currents into the Trackform, which again gives them certain advantages. The battery itself is packaged under the floor of the vehicle. We've got a sort of 350mm floor height on the vehicle, and getting the battery into that sort of small space was quite tricky, but nevertheless it's in there. We have an image of the battery on the right hand side, which essentially is in 3 compartments, two of actual battery modules, and the third one which is all the control elements of it. That's on test at WMG at the moment, but essentially the battery is split into 2 strings to give us a certain amount of redundancy, so if one fails we can still continue operating. 750 volt system and approximately 54 kilowatt hours of capacity. And our analysis, the graph below, does show you the route in Coventry, or route 1 as it's called, from the city centre, the station to the hospital. That will use approximately 9 kilowatt hours of energy, and so that indicates we've got a range of around 70 kilometres on the battery, which is pretty good. And also it will enable us to use the battery in a very narrow state of charge window and make its life way beyond 10 years essentially. And the other key point to note, because it's a rail vehicle, is it's a lithium titanate chemistry, which is inherently safe, won't catch fire, and it's a cooled battery as well to help us operate in those very hot summers that we get in the UK. In terms of charging, we've put 2 ways to charge the vehicle. First, via a sort of 20 kilowatt plug on the side of the vehicle, just for overnight charging. The second route is via an OpCharge overhead gantry type system using the OpCharge standard, and that 200 kilowatts hour work. Basically, we think we can charge for the route one, the out and back route, we can get a full charge into the vehicle in 3 to 3.5 minutes. So we're quite pleased with that. The intention was always to have charging at the end of line as opposed to sort of momentary charging at each station. So this is great because it means we can do a very quick charge at the end of each cycle, as it were, and then the short charge time should enable that short headway without creating too much of a constraint at the end of the line. In terms of the structure itself, we've got many materials involved: steel, aluminium, composites used wherever necessary. Our mass target was sort of 1 ton per linear meter. That's sort of the general consensus for very light rail. We have an 11-meter long vehicle, and we've achieved sort of an 11-ton mass of the vehicle, so we're actually quite pleased. If you look at the image to the bottom left, you'll see how sort of a cutaway of the vehicle with the battery packaged tightly in this space beneath the floor, and then at each end is the bogie, and then obviously there's a maximum amount of space for people within it. The key mass advantage we've got has been very beneficial in terms of the actual loads that are introduced into the track. So we're seeing lateral loads circa 12 kilonewtons versus 50 kilonewtons for a typical light rail vehicle, and all that gives advantages essentially in terms of how the track can be designed and produced to be as low cost as possible. In terms of the composite materials, we have included a number of different materials throughout. Just as a few examples, really, the bumper is designed to be extremely flexible, actually produced by a sort of a motorsport company. It's a carbon polyethylene composite, so you can sort of bounce off it, it'll flex and won't crack. Nice quality component. The actual cab molding you'll see is one complete piece, and that is a carbon Kevlar for sort of impact resistance and a phenolic for the fire resistance. And then throughout various other components on the vehicle, we've added a certain amount of sustainability by using recycled carbon fibre from the site in Dudley, from the LG carbon fibre. So again, things like this ceiling panel you'll see here, and for the exterior side panels and such like. In terms of the future for the vehicle, there's plenty of opportunities around. We certainly see autonomy as a major item that needs to be attended to in the next few years. We did spend quite a bit of time at the beginning of the project deciding whether to actually install driver seats on this vehicle or not. It was considered that autonomy wasn't quite ready at the time we were designing it, and so we did include driver seats. But actually, it's very important for this system to be economic and achieve a suitable business case that autonomy is a feature later on, because obviously with small vehicles, lots of them, that means lots of drivers, which means quite a high cost of operation. So autonomy is really important. If it can be achieved by 2025, that would be amazing, but probably more of 2030 would be a good achievement. There's also many opportunities that have appeared as a result of COVID in terms of air filtration, materials to manage infection spread, how you deal with passengers waiting and paying for tickets, and clean vehicles and all that good stuff. So many opportunities for R&D that we see in the future, and there's just a sort of a list of a few. And I've included a couple of projects that we have running in parallel with this one. The first one is a Innovate UK funded Resi Glaze project. So this is focused on using polycarbonate glazing, and this helps address some of the recommendations from the Sandilands report, and this hopefully will achieve circa a 40% mass saving over glass and improved crashworthiness. And the actual polycarbonate itself, I suppose the key challenges of one is the anti-yellowing element over time, and the second one is having a coating which gives you the durability, the anti-scratch coating that will essentially give it its sort of long duration that's required on a rail vehicle. Another project which is of interest called Amicable, so antimicrobial lightweight grab poles. We considered all sorts of different materials for the grab poles when COVID came along. We were a little bit late to change to a copper alloy, but actually we've subsequently looked at this project where this will be a composite braided grab pole with some antimicrobial, antiviral additives. So there's an inherently lightweight, stiff and strong grab pole, which will be again a nice thing that we can add to the vehicle. In terms of the timeline, I suppose the thing that sort of interests people are most on what the opportunities are, I suppose, is that right now where we are, end of 2020, we're very close to finishing the build. We'll be testing the vehicle very shortly, February 2021. And then very shortly after that, actually, whilst the vehicle is still testing, we'll be starting to look at planning for low volume manufacture, and then obviously helping to set up the appropriate processes to make that low volume manufacture happen, with the intention of having, I think, approximately 17 to 20 vehicles ready to operate in 2025. So quite a challenge to get there, given that essentially this is our first prototype, and will no doubt be some evolution of this prototype before production. And down at the bottom, you'll see the sort of phases, the general phases that Coventry are going through, where the consenting phase is very much the sort of Transport and Works Act order type timeline. So finally, just to summarise then, so the vehicle build's progressing well. We're really optimistic we'll be on track shortly at Dudley. Excellent opportunities for future R&D to support the programme, and also to bring all of those components, such as the battery and bogie, find opportunities to build them in the UK. And also, with this whole project really is a great opportunity to deliver a low-cost rail-based transport for medium-sized cities in the UK that wouldn't normally be able to afford a light rail system. And I think that's it from me. So many thanks for listening.
Thank you, James. Like all the best railways in the world, that was also bang on time and a great overview. Well, there's no railway without rails. So now we're going to continue with the Coventry VLR with a presentation from Micallef from the University of Warwick, who's going to talk about the lightweight Trackform. Over to you, Chris.
Hello, good afternoon. I'm Chris from WMG, which was introduced by James before me. Thank you, James. And I'm going to be talking about the other aspect of this project, which is the track development project. So, click. So I guess the first question is, why on earth do we need an R&D project to bring back trams to Coventry? Coventry had trams since the 1884. Unfortunately, it was the war that spelled the last trip of that system. But hopefully, we'll bring them back by 2025. So the question is, but why is this R&D project needed? And I guess probably most of you know the answer, and it's all to do with money. So I have here five of the more recent tram projects in the UK. And clearly this is a very high level rough number, and in this number there's a lot of stuff and rehabilitation, etc. going on. But in any case, these projects are ending up costing a lot, in excess of 30 million a kilometre, and well above that. The lastest of all of these is the one in Birmingham, where a mile of track is going to cost around 200 something million. If we put those numbers a bit into context, if we're looking at a city the size of Coventry, at a population of about 400,000 people, and we assume a best case scenario using current technologies and a very good and efficient team, and looking at controlling costs, so we're assuming a 30 million a kilometre. That's still a 1.2 billion project, assuming a network of 40 kilometres, and clearly this is unaffordable for a city this size with an income of around 200 million a year, local income that is. Still, the interest in trams has been very, very strong, and we are being pushed to understand why is this cost. And so at the start of this project, one of the first tasks we undergone was to try and understand where the costs are coming from. One of the few databases on costs available was this Edinburgh, basically resulting from the big court case there was there. And as you could see, about, in that case, around 70%, 75% of CapEx is all directly related to track build. Then again, if you go into detail of where this cost is, steel and concrete, as well know, are relatively cheap elements, cheap materials. And if you would go into the detail of most Trackform structures, you're talking about a net cost, and that's installed cost of about 2 to 3 million a kilometer. So if I give you a virgin field, probably most installers will be able to deliver a track for that cost. Because the vast majority of this cost, snowballing, is coming from all the other elements included in this aspect. And this is earthworks. And because you need to dig down, you'll be encountering utilities most of the time. You have to move them. Project duration starts inflating, related risks, prelims, project management, and all of these aspects. And the project cost just keeps snowballing and snowballing. And so the scope of this project isn't necessarily to address the cost of the Trackform itself. That's probably been done over and over, and saving £100 net on the net cost of the Trackform is not going to get us anywhere. What we're trying to achieve in this whole project is to design a novel Trackform that will in turn enable a step change, a massive reduction in all of these associated secondary costs. And the way we're trying to do this is by focusing on these three aspects. So the first element is simplifying the whole system. So, and as James introduced the work being done on the vehicle, as you will appreciate, the cost of the vehicle itself is a low cost. However, it is the design of the vehicle, so the onboard battery pack and etc., drivetrain, the lightweight structure are enabling us to simplify greatly the Trackform structure. In addition to that, time is a critical element, and by reducing the duration of the whole project, a lot of cost savings will be achieved. And probably the most important is avoid issues in the first place. So by not digging deep, by not going anywhere near all of the hidden problems under our highways, we are hoping to literally avoid most of the costs associated with these aspects. So I have here the outline of the project and the current contracted aspect of the project. Started the project at around October 2018. So let's call it around 2 years ago, 2 years and a bit ago. And the vast majority of that duration was taken by a significant requirement specification process, together with quite an extensive procurement process, a procurement for a partner. So as WMG and the council, we were looking for a track design expert to accompany us on this project. And I must say there was a big interest from the market on this project. In fact, we had around 13 bidders, all significant companies from all over Europe, and we had quite an extensive procurement process. And we're quite glad to have found a very good partner who's been doing extremely good progress so far, which is in Europe. I'll introduce them in a later slide. The current stage of the process of the project is a classical design project, started from a concept phase, a phase which has been successfully concluded, and we've been past the gateway onto the detailed design stage, which is the current phase of the project. The plan will then to go through to a final detailed optimization phase and further testing programs, but I have more information on this later on in the presentation. Okay, so I have 2 slides on our key partner in Europe and their UK subsidiary Rendell. So in Europe, as I introduced, were our the winners of the procurement process for a key Trackform design partner. They are an engineering consultancy, pure engineering consultancy in the areas of transportation, infrastructure, and building and energy. They have purchased a while ago Rendell, which is a UK-based again consultancy, and between expertise specifically in highway construction at Rendell and the Trackform expertise at Ingerop from France, and the team at WMG. We are leading forward this project. One of the key aspects on Ingerop which helped them winning this contract was their expertise in light rail, specifically in light rail and specifically in Trackform engineering. So as you can see from this, they probably have their finger in the vast majority of light rail projects in France and also in the rest of the world, as you can see here. And Ingerop tend to be a company involved in the actual design and engineering of a Trackform rather than necessarily simply the alignment of a route, which is what we are after in this project. We are after a novel Trackform specification. So I'm going to now have the next section of this presentation is looking at the requirements we have specified for the design of this Trackform. And some of these requirements are significantly different from requirements set for any other light rail Trackform, which you will know. And I'll try to highlight some of these. There are 5 key requirements which differentiate what we're trying to do in this project from other typical light rail projects. So this slide is a summary of 12 key requirements, which at the end of the process helped us choose between the various concepts which we came up with. And these were 4 key categories of requirements. We had the first group of requirements, which were specifically set to achieve our strategic objectives. We had a whole set of requirements, which was just quite atypical from other Trackforms, looking at defining a new management strategy to deal with utilities. Then clearly we set ourselves quite a lot of stringent delivery route delivery requirements, and also all the other operational requirements you might imagine, such as maintenance, etc. So clearly, well, we're talking about cost. So obviously, one of the first requirements we set was a cost, a capex requirement, and we have set ourselves a target of around 2 million per meter per single track. Sorry, 2 million per kilometer of single track. Now we did quite a lot of work when defining the requirements to detail exactly what we're including in this cost. And to summarize it, essentially we agreed with the council that for that cost, what we're talking about is taking an existing highway, digging it down and building up the Trackform and repaving it and giving back essentially a highway with an embedded Trackform, pretty much as shown in that photo. Second requirement, and probably one of the most critical to achieve what we're trying to do, is a shallow Trackform structure. So we have come to an agreement that our design needs to be limited to 300 millimeter. More specifically, 300 millimeter is a total dig depth. So the aim would be to just bring a normal milling machine onto our highway and mill down to a depth of 300 mil. And within that depth, then we will build up whatever structure, whatever concept we come up with needs to sit within that envelope. That was mainly based by the NGUJ guidelines, which specify that, well, all utilities are going to should be, let's put it that way, at a depth of lower than 450 mil, and safety critical utilities should be at a depth lower than 600 mil. So in a way, we're quite we have put quite a safety margin there. Another requirement was that we need to be able to accommodate for surface access chambers within our Trackform. And the reason for this is that, yeah, our highways have a lot of these access chambers, and moving these access chambers have a budget will typically end up costing more than the budget we have set for the Trackform itself. So being able to leave access chambers where they are is also of critical importance. Third requirement, again, so the whole strategy of the project is that we are going to just dig down the top 300 mil and then live with whatever we find there in the vast majority of cases. So it's no point to design, let's call it a marshmallow trackform structure, which cannot survive unless you have a perfect subgrade foundation. So we did quite an extensive analysis of the typical structures we tend to find under our highways. So we were lucky; we had quite an extensive database of historic cores on roads around Coventry. And well, the analysis basically yielded a quite unsurprisingly, a vast majority of a vast variation of road structures. And hence, the only reasonable assumption to go with is that we had to design something for quite a, let's call it a soft foundation layer. So we specified ourselves quite a conservative bearing capacity of around 30 megapascals. The last two requirements I'm going to talk about relate to our strategy with dealing with utilities. So, as you well know, there will be a lot of utilities hidden in our buried in our highways, and in typical cases, most of these utilities are relocated to allow the trackform to sit on top. Now, in some cases, that is mostly occurring because that is happening because of actual physical clashing. But in other occasions, it is simply occurring for the necessity to allow future access to these utilities. Now, the strategy we are adopting in Coventry is we are saying that let's transfer the risk onto the trackform delivery company. So, and we are going to allow the utilities to treat this as if it were a specific a normal road. And in order for us to be able to tell that to the utility owners, is we set on ourselves this requirement that we are going to have to be able to remove the road, the trackform plus the road, as if it were a normal road. So we are not hindering the process or the speed of a utility company to access their utility during an emergency repair necessity, essentially. And then again, related to that, but also to the overall strategy of the project, is the speed of reinstatements and installation in first place. So we've set ourselves a speed of about 60 meters per day per team for the fresh installation of the track. But we've also set ourselves another requirement, which is that of essentially being able to reinstate a small section of track, which should take 24 hours or less. And again, so this is dealing with the emergency scenario. Throughout this, it has been critical that we follow quite a robust design process. So we followed the UK's Design Council guidelines, and because what we're trying to achieve is a very robust trackform design process, so that all of the results of this program can be carried forward and adopted by future cities, hopefully. And most of this program, the aim will be to publish what we're doing and achieving in this program. We have carried out, as part of our design process, after this extensive requirement specification process, we've also gone through an extensive benchmarking exercise where we studied all of the existing trackforms and compared them against our requirements. We've carried this. The aim is here just to give a very brief overview of what we've been through, but we've carried out extensive structural analysis and also cost and environmental performance benchmarking, breakdown and benchmarking, to study exactly what is and to see how they fit against our requirements.
You have to hurry along, please, a little bit, Chris. You've got 1 more minute.
Yes, I'm almost done. So I guess this is maybe a disappointing slide because I guess most of you have been hoping to see the concept itself. The reality is we have a patent which is being filed hopefully by the end of this year, but if not, definitely January, following which we'll be looking at engaging once again with the industry to discuss the future phases of the project. which will include an extensive testing program, the construction of a test track, and the necessary testing of this novel Trackform. And that brings me to an end within the minute given. You're mute, Sam.
Sam, you still muted.
Classic. First time presenting, my apologies. So thank you, Chris. Some very interesting innovations there. Now, we're really thrilled to have Amanda Roper from the DFT, who's going to give us an update on potential reopening of some clotheslines. It's something very close to my heart, as I was born next to one of the proposed locations, and I'll let you guess which one that is from my accent. Unfortunately, there's a camera issue, so we won't be seeing Amanda today. We'll only be hearing her. So without further ado, Amanda.
Thanks very much, and good afternoon, everyone. Apologies for the technical hitch. Hopefully, I won't accidentally be on mute at any point, which is the bane of my life during this lockdown period. So I'm Amanda Roper. I'm the Deputy Director for the Restoring Your Railway programme in the Department for Transport. Restoring Your Railway, you've probably heard, is very much a ground-up, locally driven programme of rail proposals, which really aims to take the opportunity of finding different ways to get schemes in place, from early ideas through to delivery. So I'm really aiming to give you some food for thought, as finding ways to lower cost and reduce time, as my fellow panel members have mentioned, is really a consistent theme. And while this isn't necessarily specific to light rail, innovation is definitely the word of the day. So on the first slide here, I'm just giving you a quick overview about Restoring Your Railway and the aim. At its heart, Restoring Your Railway is about reopening lines and stations, reconnecting smaller communities and regenerating local economies. So it's about improving access to jobs, home and education, and we're trying to throw our arms quite wide in how we take the initial approach, and have invited various bids and are working with proposals. So back in January, which may feel like a long time ago now, this year, the government, our ministers, pledged 500 million for schemes which are at different stages of their life cycle, or targeting different rail challenges. And this is all in the context, as I say, of reconnecting communities and levelling up. But what we've really tried to do is emphasise it's about finding the right transport solution for communities. So even though the avenue is through rail, we kind of aim to give promising proposals a home, or find a way forward for them where it is possible. So to that end, there are three pots, as we call them. There's the New Stations Fund, Advanced Proposals, and the Ideas Fund. So I'm going to briefly cover the first two, and then come on to the Ideas Fund, which I find particularly exciting. So first, the New Stations Fund, which we cover in more detail on the next slide. So it basically does what it says on the tin, not to put too fine a point on it. It's about developing proposals to build new stations, because why the Restoring Your Railway overall aim, it stems from, you know, reversing beaching and that kind of idea. There are, of course, areas which have never had a station, or stations have been built on, and that actually needs to roll with what the current context is, not just what it was like in the 1960s. So this is one of our most established funds and has been running for a few years. It provides up to 75% of the cost of building a new station, and helps to give local communities improved access to rail across England and Wales. So as I mentioned, we've had 2 rounds before this year, and the third round closed back in, I think it was June or July. And we've now approved funding for the third round, which is actually an uplift to what was agreed back in January, and only so far announced the development of the stations you see there on the slide. So Edgenswell, Thanet Parkway, St Clears, and some development funding, because there was real potential around Haxby and Deeside stations as well. And while it may not automatically be obvious in terms of, you know, where does this drive innovation, one of the key things around new stations, as well as making sure we're providing access for all, is, where there's opportunity to have those modular builds. And I know Network Rail have been working closely with the New Stations Fund team as well as promoters on how we can actually learn and reproduce what we've done in various areas around the country, although always allowing for every site has its own unique requirements. So that's New Stations Fund. Moving on to advanced proposals. So we've called them advanced proposals really to try and describe them in a clearer way. And these are really around proposals that have been around a while. They might have been working away in the background, already started, and that promoters have come forward. They're well through strategic outline, business case, and those sort of investment decisions. So this part of the fund really gives support for lines and stations already being considered. And we're also using the Ideas Fund, which I'll come on to, as they progress. If they have potential, then they'll end up in this bracket. But essentially, it's to help accelerate the development of closed lines and stations, and really move those ahead in a focused way. Again, looking at how we can lower costs and increase our pace collectively as an industry. So a couple of mentions there for the Northumberland line, or some of my note is Ashington, Tyne and Blythe, and also the reinstatement of Oakhampton to Exeter line. So these are sort of just two of the examples we've been looking at and are moving ahead. So we're currently planning a formal assessment of schemes to determine potential funding awards in the new year, because we've had a few come forward for consideration and application, but that is part of the ongoing work we are doing. So now on to the Ideas Fund. This is the newest part, or the newest entry in terms of the overall Restoring Your Railway programme, but I find it the most exciting part, really, because we're getting in with promoters at the earliest stage to really get that specification right, to explore options to restore lost connections to communities. Again, coming back to beaching reversal, that's one of the key drivers. But it's really, again, trying to provide an opportunity to be a gateway to the department and to government to a certain extent, but most importantly, reconnect communities, and that's what it's all about. So we've had a very high level of interest, if you might have heard or seen, across the two bidding rounds we've held so far. So the first round closed in March, and ultimately 10 schemes out of the 60, I think it was, we received were awarded development funding. And since then, we've been working with successful promoters and MPs to really work through and guide them on how to develop a strategic outline business case without having to write War and Peace, which I know will be a familiar experience for some people on this webinar. So you'll also be aware that it was great to be part of the spending review announcement and to be included in the National Infrastructure Strategy. So we had another 15 round 2 schemes announced, and we had lots of really high quality bids. Again, I think it was about 50 for that. So overall, we've had 110 plus. So we're really starting to work with those successful promoters. And it's really about then whether the strategic outline business cases stack up and whether they move on to the next phase. So the next slide shows the spread across England and Wales. As you notice, there's not a huge number in Wales, and that kind of reflects the volume of bids we've had. But it generally has a good strategic spread in terms of the overall strategic benefits. And when we were assessing the bids, and then the panel considered the overall assessment, and the panel included Sir Peter Hendy and Isabel Dedring from Arup, and was chaired by the Rail Minister. They really considered a wide range of factors to determine which ones were most likely to achieve the goals of what we want to do. So again, that's the reconnecting the communities, regenerating local economies, but increasingly as we go on and progress the schemes, we're really looking at what the detail of the socio-economic benefits are, what are the proposed services, what are the infrastructure requirements, all in the context of, is this the right transport solution? So where the funding might be asking a question, and that's one of the things we've been pressing with the feasibility, it might be that it's not known what right is the way to go. So we've been encouraging people to be specific about what the funding is required for, and so it might not be heavy rail, it could be light rail, and then we aim to help find the right home if it really stacks up. So in summary, and I hope that wasn't too much of a race through, we're really looking in Restoring Your Railway Fund to support the restoration of rail stations and lines with the high level strategic focus of reconnecting communities and levelling up. There's also opportunities within here, because they are smaller schemes, to challenge the cost and time taken for rail projects. And I really appreciate that is easier said than done, but we see it as an opportunity to, let's see what we can do here and do with people like you on the call, as well as our colleagues in Network Rail who've worked really joint effort on this with us in terms of working through all these bids and giving them some real scrutiny. So where are we going next? We've got round 1 and 2 ideas fund schemes, which are working on the strategic outline business cases. As I say, if they stack up, they'll be considered for further funding. And then for the 3rd ideas fund round, which we're anticipating will be our last for the time being, that will really bring our collection of schemes to a close in order to move forward with the portfolio. So really exciting times. I've put the team's contact address on the slide, so if you did want to drop us a line, feel free. And then I think that's all I was going to cover for today, and look forward to hearing your questions. So many thanks for listening.
Thank you, Amanda. That was very insightful. The questions are flying in on my other screen here, so if you could stick around for the Q&A, that would be fantastic, and we'll be able to put some of those to you. I did actually put forward proposals for a station outside my house and another by the local pub, but I can only imagine they've been lost in the noise. So now on to our 5-minute pitches, and to start us off, we have Noel Dolphin, who's going to present to us an overview of the battery charging infrastructure at the Dudley test track for very light rail vehicles. Over to you, Noel.
Yep. Hi, Sam. Yeah, hi, everyone. Good afternoon. I'm Noel Dolphin from Furrer+Frey, and I've got 5 minutes to talk through some of the battery charging for the Very Light Rail project, in particular test track in Dudley. And my presentation really follows on from James from WMG's presentation, and also a little bit from Christopher's track presentation as well. So hopefully I can. Yeah, there we go. So yeah, setting the scene. So yeah, as a company, Furrer+Frey, we've worked in electrification for almost 100 years. For 90 of those years, that's been conventional electrification. So for tram, trolley bus, mainline, metros. So yeah, overhead line you see above the track. However, for the past 10 years, we've also been working on developing battery charging technology for public transport. So tram wires, trolley wires, overhead line are great, but in certain situations, batteries also provide a real benefit and a real solution. So for the past 2 years, we've been working towards testing at Dudley that will commence early next year. So yeah, where did our charging journey started? Well, it didn't start in rail, it started in buses, and as I said, we've been working on charging technology for 10 years, and that, for most of that's been in buses, and for that whole time we've been working on opportunity charging, which James mentioned earlier. And opportunity charging is essentially just providing top-up charging, normally at the end of routes. So rather than having large batteries that vehicles lug around all day, it's having smaller batteries that are continually topped up throughout the day. That means smaller batteries and more space for passengers. It also allows for a distributed energy grid, so there is the options to place chargers where there is capacity in the grid rather than charging a large number of vehicles solely in a depot. I've got a few photos from a few projects we've worked on in the past couple of years. Spain, Belgium and Switzerland are in those photos, and it's worth noting with at least 2 of those projects, they were combined with battery banks that were powered by solar and wind power. So there's also a strong link into renewables for cities as well. And so from buses, we started talking with the team for VLR and how can we make something interoperable? How can we use the same technology to charge buses, but also charge rail-mounted vehicles? And the real reason for that is if you can have common infrastructure, you can create a more standard product and you can considerably reduce costs. So yeah, this is where we are. We've been working with WMG, also with TDI, who are developing the vehicle body. WMG are doing the integration, and now with the test track in Dudley and the Black Country Innovative Manufacturing Group. So, and the first trial is in January, February next year, with real operations beginning in February. So it's happening really, really soon. So yeah, you'd have seen the picture on the left, the design in James's presentation. Manufacturing of the charger is currently underway. The picture on the right is a part assembled unit that was undergoing testing earlier this week, and on the left is a schematic. A couple of points I want to highlight is that there's a tall mast, and that contains all the power banks, all the electronics for the system. So with a lot of industrial charging, you'll see some form of a charger and somewhere down the road a grey shed that has a lot of power banks, whereas in this case everything's in the charger, and that's the mast is 80 centimeters by 80 centimeters. The charger itself is initially a 200 kilowatt charger, and the final version coming in April will be 450. There's a pantograph on the charger, and again that's to keep vehicle weight down. So the pantograph and as much infrastructure as we can have as possible is on the charger. The vehicle just has contact strips, which are relatively small and light. The size of the charger, we've tried to create a common charger, which we use in buses, but it's also designed to accommodate double-decker buses. So yeah, there's a single piece of infrastructure, whether you're having a VLR vehicle, single-decker, double-decker, it's a single unit. And again, that's been about lowering costs. For the first 2 months of next year, there's a lot of construction going on the site. So from the track presentation, that there's at Dudley, there is existing track in the Dudley test track. The new track layout is being developed in spring next year. So when we get there in February to test the vehicle, actually all the track won't be in place. So we've had to develop options to be able to move the charger around as the track is developing around it. So we'll be testing on the existing track layout, moving the charger to allow them to move that track layout. And so yeah, on the left you can see there's a large metal plate at the bottom attached to the charger, and that essentially acts as a gravity pad. So it's not bolted to the ground, it is movable. And then when we come to the final installation hopefully in April, we will have a more conventional foundation. Yeah, so here's sorry, second last slide. So we've got some screenshots here of the Very City software, which is what we're using to monitor the performance of the charger in Dudley, and that will be an open platform. So us, the operator and the vehicle testing team will all be able to live see performance of testing. One other last point I want to make before I entirely run out of time is we worked really hard this year to try and build the charger, the test charger in the UK. COVID slightly screwed that up as we couldn't get teams over to train our UK team. So the trial charger has been built in our parent company in Switzerland, but we hope that the main charger and subsequent chargers will be built here in the UK, COVID allowing. So yeah, I'll let you go there. I'm sure we'll take some questions later on.
Thank you very much, Noel. Noting James's times earlier, in the time for that presentation, we'd have got a full charge and we'd be back out in revenue service. So we have John Hammond from Precast Advanced Track to tell us all about their modular slab track. Over to you, John.
Okay, thank you very much, Sam. Thank you everyone for allowing PCAT to do this elevator slot. We have worked with the Innovate UK previously and won funding, but PCAT is a smart track system. And like the government, we want to build back better. You know, we have a history of building railways, which is exceptional. And we need to think about future materials. So greener, leaner, cheaper, definitely an aspect of what we want to achieve, but safer and also smarter railways. Who are we? Well, PCAT, I'll jump in about the slides, I'm sorry, here. PCAT was established in I'm sorry. Can you?
Would you like me to run them for you, John? I'll run them for you.
Okay, thank you. Yes, PCAT is established in 2010. We're a Midlands-based company, and we won an award at the Rail Live in 2016 for our low impact track slab. Our slabs are made off-site, stitched together, 500 metres to 100 metres a day in street, and the slabs can be easily taken apart and replaced. And really, we are transforming railways and tramways. Our partners have been Barchip, who make macro-synthetic fibres. They were installed in the Japanese high-speed railway, and we were the first company ever to put them in precast slabs. And the big value with their carbon fibre materials, polypropylene materials, is to reduce the need for steel in the slabs and reduce the carbon footprint and impact of carbon by 70%. That's been happening since 2010, but now we have a new partner that's bringing a new type of concrete additive into this industry, which is Tritonite. And my colleague Phil Downs will talk about Tritonite.
Yep, thank you, John. Good afternoon, everybody. Yeah, Triton Norway, a company who does quite a lot of innovation. So we've got quite a few innovative products, from controlling water in structures to recycling plastics, and lastly to looking at a concrete additive. So it uses nanoscience technology and basically increases the strength in tension by a factor of 2 and in compression by up to a factor of 3. So what it means is that instead of your standard mixes that you would normally use for, say, a C30 mix, you end up with something like a C50, C60 mix. So again, a significant reduction in cement, and as John said there before, significant reduction in carbon because of that. We can effectively up our concrete strength to around about C120 as a plain piece of concrete, but with reinforcement get up to something like C150. So this is really the game changer, especially in things like slab track for John with PCAT, which makes, if you like, the strength of the panels much more, and therefore the depth and section required is much less. And again, means that we're using less cement and less concrete, so reducing cost, reducing the carbon content. But of course, it's not just the cost of the material itself, it's also then the handling of that and moving to site, etc. What it also does as well is it makes the mix 100% waterproof, and it probably gives a waterproofing factor higher than anything currently available on the market today, by about a factor of 10. So basically it becomes totally impervious to water. And again, using with the plastic recycled and rubber in there as well that we can use rather than steel. So again, reducing our carbon content. So the addition of really is just about 2.5% is what we look to add into the mix. So a very small percentage, if you like, that goes into it. But as I say, reducing CO2 content by probably over 25%. So whole life costs and lower CO2 emissions, and really now enables a complete new generation of track design. Looking at the whole life plan for that, and also looking at how we make this greener. John, over to you.
Hi. Yeah. Yeah. Thank you very much, Phil. Yeah, my history is highways, but my granddad in the bowler hat here was in Manchester. This was the first ever passenger line in 1900. And really, it's a ballasted track. His whole gang of men obviously working on the ballast. I don't know what we've been doing since then, to be perfectly frank, but there we are. Okay, the next slide. So what's changed in the last 200 years? Why PCAT are delivering a next generation? And so 200 years, nothing's changed really on ballasted track.
You have to hurry you guys along, please, John and Phil. You've got 1 more minute.
Sorry, HS2 is going with slab track. PCAT actually is greater strength, durability and lower cost, lower impact on the environment. We've got inbuilt resilience, drainage and intelligent monitoring, so air tracks are very safe. We've 495mm reduced in depth compared with mainline ballasted track design, but in the highway, our slab will be just 280mm in thickness. So Coventry, we've got a system there for you now if you wish. But indeed, we can actually take the slabs out and put them back overnight. So it's a very challenging type of infrastructure that we have developed. Okay. So PCAT, we build back better, greener. Ballasted track in today's climate, I don't think so. Leaner, faster, stronger. No wet trades, no pump cement, no pump concrete in PCAT. And virtually no maintenance, low whole life costs, very, very low whole life costs. Our design life is 120 years plus. Sorry. Somebody's safer, intelligent monitoring. So basically, air slab on earthworks will know when there's any stress occurring to the foundation, and a trip-free surface for people to walk on. And smarter, yes, we're truly modular and completely weather resilient. So the problems with extreme weather events are not a problem for PCAT. We've had, as I say, Innovate UK support for PCAT's ideology that built the track at Long Marston. But with Tritonite and Barchip together, we believe this is going to be a game changer for both normal railways and light railways and very light railways. And finally, this is what we can achieve with upgrading and ballasted track 500 metres a day. And actually,
thank you, John Phil. I'm going to have to stop you there. We're way over time. I've got questions from the panel on my other screen. So
thank you very much. Cheers. Okay.
Thank you to John and Phil. If I could ask all of the speakers from today to turn back on your webcams, then we can see you all pop up at the top again, please.
My webcam doesn't seem to want to start.
Okay. Yes, so big queue of questions for our Q&A session. We've got till 3:30, so hopefully we'll be able to get through quite a lot of these. I'd like to start with you, James, as our first speaker. And I'm actually going to start with a question I wrote down myself. So you followed a inside to outside build method. Can you elaborate on why that was chosen? You're on mute there, James.
I would say it was an extremely carefully constructed strategy right from the beginning, but I think it evolved actually based on the way the materials were coming in and the supply chain because of COVID and such like. It just basically was devised to manage the situation, but
okay.
Actually works quite well.
What standards have been used for fire performance? This is from Malcolm DeBell.
Yeah, so I sort of didn't make
barriers.
That's all right. I mean, I'll just give a brief answer on this. The tramway principles and guidelines has been like our Bible for this vehicle. I think there was always some vision at the beginning of the project that because it's you know, sort of a road-going rail vehicle, we could sort of go with some sort of automotive or bus type standards. But the reality is, I think we've been stuck with the tramway principles and guidelines, and that's where, you know, what we followed very much. And HL2 is the fire standard we've gone for interior components.
Okay, and can you tell us the same question, but for your crashworthiness testing, at what levels of
yeah, again on crashworthiness, very much driven by the by what was in, you know, the TPG. It's pretty vague in the TPG actually. It more comes down to whether the ICP is content. But essentially, what I've got a note from one of the guys, James Winnett, working on the project, is essentially we've done quite a big analysis of all the collisions that have taken place using similar vehicles, buses and such like. Looked at EN 45545, ASTM and Euro NCAP standards. We've used finite element analysis to assess the performance, and we're also doing further work now to actually understand the most appropriate scenarios to crash and do further analysis on the structure. So it's work that's actually been going on in parallel, really.
And with your composite structure, does that change your, if there was to be a crash and you were looking at your repair afterwards? Minor nudge, I understand, are the most common incidents on tramways. Does it change your repairability somewhat?
Certainly. So the front end of the vehicle has been, you know, there's obviously a crash structure behind the front bumper, which is designed to, you know, to absorb impact and be cheap to repair. The side panels are recycled carbon fiber, which again are designed to be flexible, hopefully, and not break straight away, but relatively cheap to replace. So I think these are sort of things that may evolve as we get towards a production vehicle, and, you know, you may decide to use it like a self-reinforced polypropylene composite, which is much more resilient and robust and cheaper to replace. But I think they'll all evolve over time. If you spend more on tooling, you can use thermoplastic that maybe have better resilience.
Okay, I'd like to move on to Chris. So Chris, it's a question from Louise Shaw. Louise, CapEx is one thing, but OpEx and disruption risk is another. How will the utilities access their services below the track? What level of disruption will it cause, and who will cover the costs of the disruption? Bearing in mind that an increasing proportion of utility street work is now on an emergency nature rather than planned maintenance.
Yes, so well, in essence, this is the fundamental crux of the whole project, right? So firstly, we have to deal with the fundamental aspect of all of this. The utility companies can actually force us to move their utilities. So this is the first thing which we cannot escape from, right? It's law within the UK, and it's one thing which has formed our whole strategy in essence. Now, another word in that sentence is risk. And that is exactly what we are dealing with. It's what we're doing is going to be a risk-based approach. So we're studying statistics of the last 15, 20 years, and we're looking at what failures are we actually encountering. And clearly, this project is not about just going blindly, milling up a road and putting our Trackform, and then we'll see what comes back to haunt us tomorrow. Obviously not. It's still gonna require all the usual scans and analysis and detailed planning. But what we're doing is, let's not move utilities which we don't have to move. So when our risk-based analysis shows that a utility is fairly safe, if it's a fairly modern plastic pipe which will live 100 years, which is much more than the lifetime of our track, then why on earth move it, right? If it's a stretch of road which is highly risky, where there has been failures over the last years, of course we're gonna move that utility. So it's gonna be a risk-based approach. We're not saying £0 per kilometer of utility work. We have quite a significant budget. Almost it's equal. The budget we're allowing for utility is almost the same as the budget we're allowing for actually the Trackform itself. So we're not saying zero utility diversion. We are dealing with the risky ones, but others which we don't have to move, we'll leave them there. But that doesn't solve the whole problem. We still have to give the utilities the chance that if an emergency occurs, then they can actually access it. And that's why we are saying it's going to be a lightweight, shallow Trackform, which they can basically just rip up as if it were a normal road. Now, clearly, the risk is all on the operator in that aspect, in that scenario. But we're dealing with that also. If the Trackform in itself is cheap, we're looking at building a resilient network where we'll be able to put maybe diversions. And again, given the reinstatement of the track itself is quite quick, we'll also hopefully be able to put the service back as quickly as possible.
So your target price that you stated, which was £2,050 per linear metre Trackform, includes moving utilities that may get in the way, utilities that includes utilities that may not be buried deep enough, for example.
No, the 2 million is specifically just no utilities involved.
No utility work.
The budget for utilities movement is in the 10 million project overall system cost.
Okay. Does your development include switches and crossings and special track work?
So that's again quite a specialist area which we're dealing with. The Trackform concept which we've come up with will allow us to use to support movable track sections. So we're dealing with that aspect. But clearly, again, that highlights the aspect. Putting a movable Trackform over a risky utility area is madness. It's just too costly to justify that risk. So in that case, our view is that probably we'll be putting movable track sections at a very, very low risk section, which hence probably will make much more sense to use conventional current solutions rather than trying to develop something which will just be more costly for no reason.
Okay, understood. I'd like to move on to a few questions for Amanda, if you're still on the line, Amanda.
I am, yeah.
Oh, okay. So let's start with a question, quite a spiky question actually, from Clive Kessel, which says, it seems this is all talk, but not much delivery. When will we see the actual first line reopening?
Well, thanks, Clive. That always tends to be the main criticism of government. So we are really aiming for delivery in the next couple of years. So if we look at new stations, they tend to be the quicker things to build. So those that have had funding, looking by 2024. And then for the more advanced proposals, we expect to see a couple of those possibly earlier than that. And then the Ideas Fund ones are, as you might appreciate, more tricky because we're working quite closely with the local communities and actually working up the spec. They're at such an early stage that it's difficult to say, but essentially there's a lot behind this in actually, seeing it on the ground. The first actual reopening I certainly would like to see in the next couple of years.
So my takeaway from that is that you're promising it will be in the next 2 years.
Nicely done, but I think I've been quite clear.
Okay. How is restoring your railways benefiting from the speed initiative?
So I am part of that initiative as well, working with Network Rail colleagues very closely, using Project Speed in terms of slashing the cost, halving the time, slashing the cost, and really are already applying it to some of the advanced proposals, and will be applying how we can actually make a difference to those schemes that do make progress from the Ideas Fund. So it's really benefiting both from the practical changes where Network Rail are looking to make working with us, and also from what we're trying to, how do I describe this? A change of mindset in terms of how can we do these things better and actually push back on what is standard. So heavily involved is the shorter answer.
Heavily involved with Project Speed.
Yeah.
A comment more than a question actually from Graham Collett. There's hardly any schemes in Wales. Can you speak more about that?
Yes, of course. So Graham, we picked that up as well, and it's one of the challenges of asking for proposals to come forward, and there's also the sponsoring MP element. So really we're in the hands of those who wish to apply and support certain proposals. So it's certainly not by design.
Not by design, it was just where the proposals came in from.
Exactly, yeah.
In Wales. Yep. Okay. Is there a list of the 110 schemes already applied for? Is that publicly available?
Yeah, that's on gov.uk.
They're on gov.uk. So that answers Edwin Barker's comment, who said, it would really help provide focus for round 3. To put forward schemes that lie outside of the 110 schemes already considered. Richard Jones, who's obviously heavily involved with the BCIMO, has asked, if the 111 schemes proposed 111 different solutions, do you think this could possibly represent value for money? Could a common system with configurable variants and lower cost be better value and allow more schemes to be viable? And we all know what Richard is pointing towards here, given the theme of today's session.
Yes, yes, certainly. So the 111 schemes don't propose 111 different solutions at this stage. I mean, rail does tend to be quite tailored. But yeah, one of the things we've often talked about is a common system, but it is easier said than done. So it could do, but we have no data in terms of representing greater value for money or not. But yeah, we're always thinking about what is possible with colleagues in Network Rail.
Excellent. And for those who haven't seen it, my boss, David Clark at RIA, has just posted the link to the reopening of Beeching area lines and stations in the chat. So if anybody's interested, go away and have a read of that. I'd like to move on to Noel. A couple of questions coming from Noel. Technical one from Clive Kessel. What is the connection between charge point and tram?
So it's yes, good point. Good question. Sorry, it's worth pointing out the pantograph you see on the charger isn't a traditional railway pantograph that you see on trains. So they would normally have carbon strips on the top. This pantograph has copper strips, and the vehicle has copper strips as well. So it's a copper to copper connection, and it's governed by the OpCharge standard. So if you Google OpCharge today, I'm sure you can find their standard for that connection.
Sure. So it looks like obviously you showed the slide with I think 5 applications that are live currently. Can you tell us if anything?
Oh, sorry, that was just an example 5. Yeah. I think we've probably got about 30 projects that already have been running for several years.
And they're all buses?
But until now, always on. Yeah, until now, it's always been on buses. Yeah, so this is the first VLR use. There isn't actually very much change. Sorry, it's still the standard charger. The big difference is just how they communicate with each other.
And presumably you know where it's parked laterally rather than where the driver left it, because the track governs that. It makes your job a bit easier, so it'll be a bit cheaper, right?
Yeah, so we've tried to make a standard as possible charger, really, just to reduce costs. There is a reasonable amount of allowance, because trains can also stop in not exactly the same spot as well.
Yeah. From James Golding, who says, I think the challenge you will find here on operational charging is the DNO requirements and availability of power to the operational pantograph charging pole. Says they've tried it in London but could not get the connection. And I know you've added a comment to that in the questions tab, but if you just talk a little bit more about that.
Yeah, so I think that is a challenge, but some areas have grid capacity, some don't. One of the advantages with conventional electrification is it is its own transmission system, so that is a limitation. With opportunity charging, there is the ability to move the charger to a location on a route where there is grid capacity. If, for instance, in one side of a city there isn't capacity, in the other there is, you might be able to only have it at one end of the line, but you need to find location where there is capacity. If not, you need to get additional capacity. Even with conventional overhead line, at some point you need to connect it to the wider grid. So you always at some point need a connection to the grid.
Thanks. Question for John and Phil. Tritonite sounds like the opposite of kryptonite. It sounds like it makes everything stronger and better. What's in it? You're on mute there.
There we go. That should be all right now. Yes, it is. That's our little secret, which makes it work. So that's our patent on the product. But yes,
public domain, surely. Sure, you can tell us.
I'd love to, but it's Christmas. Can't give too many Christmas presents away.
It sounded like some fantastic claims of what it can do for concrete. Are there examples of it being used already, deployed scenarios? Can you illustrate?
It's right at the start of its life, really. So it's currently had some testing done around the world, which shows, if you like, compared to a standard concrete mix and adding Tritonite into it, then the improvement which can be gained. So that's where it's at. There are plans in other places around the world to actually incorporate this now into some structures. Obviously, one of them that is really good is looking at things like tunnels, dams, etc., and obviously also large construction sites. Mainly because if you think about a multi-story building that's reinforced concrete, then first of all we don't need the steel. We can use much cheaper components. The other thing is, even if you do use steel, it doesn't rust because it's waterproof, so the water doesn't get in. But it means that probably looking at a sort of a 20-story building, you can probably add another 2 stories on because of the reduction in weight of the building itself. So effectively, the foundations you're building will allow you to build higher. So looking at city developments, then a big impact.
Yeah, and you were talking about the inclusion of rubber.
Yep. So
how does that affect non-exhaust emissions?
Well, yes, I would think I could come in there if you want. Yep. Phil, yeah, obviously the slab track is precast, and the concrete, the finished concrete will be whisper concrete in the surface. So the crumb rubber will be encased in the low level to the slab track. So
okay, so it's not an exposed layer then.
Yeah.
So similar as you would use steel, then effectively reinforced steel structure, you don't see the steel in it. It's internal.
Sure. So can the track be retrofitted into guided busway track?
Yes, we've looked at a potential project up in north of England, actually, with a client where the guided busway actually is. They're looking to actually put trams along there now. The width of the guide rails can be planed off, and we can then go in there and actually lay slip form concrete right across the track and then put an embedded rail in there, and that will be quite an inexpensive operation. So yes, it is possible. I've done a design for a client, so if anyone's interested in that particularly, we can show them what we've done. It is for the lead busway that I've done the design.
Okay. James, another question coming for you regarding the driver and driverless operation. You stated you chose drivers because driverless wasn't quite ready at the time you were doing development. Do you see a change to driverless before deployment? Do you see virtual coupling being a facility that you can offer with the first iteration?
So yeah, I mean, virtual coupling was always something we talked about as being a possibility to increase capacity. Whether or not it can be achieved before 2025 is a real question, and one I don't have an answer for right now. It would be lovely to think we can do that. There are systems appearing in Europe that may or may not be applicable. There's clearly some regulatory aspects that need managing in the UK. Not quite sure how it can be done yet. Whether it's via a central control, which can then a single driver may be able to control a number of vehicles, or whether it's a fully autonomous system or whatever. There's numerous things that need to be done, and the reality is, I think, we're at the beginning of that journey, and achieve it by 2025 might be a bit of a stretch. But we keep applying for Innovate UK funding, and we keep trying to pull together consortiums to try and make it happen. So, if you're interested, do give us a call.
I'm sure some of the members on the call may well be. You talked about your battery lifetime, upwards of 10 years, your modelling suggests. Do you have any idea of your entrained carbon in a vehicle and how that compares to a traditional light rail or heavy rail? It's a hot topic.
If I could pass that question on to someone else, I would. I'm afraid I don't know the answer to that one.
No?
But certainly, a lifetime of certainly 10 years plus on the battery was a key thing. I mean, it's clearly an expensive component. and you don't want to be throwing it out very soon. But actually, with the chemistry we're using, and if you can keep it in a narrow state of charge window and manage temperatures effectively, you can get 15, 20 years out of it, which would be very good.
Okay. Could you just give a little indication of the accessibility concerns, something we haven't touched on in the presentation? So there's a picture of a wheelchair parking zone on one of your trams, and they're clearly very low floor, but just how well?
So, all I know is we are RVAR compliant. We have so there's 3 flip-up seats on board, and in that space is a single wheelchair space on board, basically. So
Okay.
I'm hoping it's as good as it can be.
As good as it can be. A few more questions coming in for Amanda. Ask if you're still here, Amanda, because we can't see you. I assume you are.
Oh, I am hiding. Yeah, I am here.
Yeah. Well, it's disappeared off the bottom of my screen. Just a second. So you're working closely with Network Rail on the range of reopenings, but how are you actually assessing the range of options available from very light rail, through light rail, perhaps tram train, heavy rail? How is the assessment being conducted?
So the assessment in terms of working up for the Ideas Fund one, quite often the promoters have come to us with sort of various options, and they are then building on that assessment as part of their feasibility work. So it's really forming part of the business case. And then in terms of working with Network Rail on what we do to assess the possibilities and potential options, so we're helping check out the full range. The lead in on light rail in Network Rail, Simon Coulthard, who I think was speaking to you this week as well, and he links in with UK Tram and others and provides advice that way.
But is there a formal process to decide sort of which formats would be? Sorry, has the formal process been declared to decide which format would be suitable for each location? So I think from the supply side, obviously our members are going to want to be looking at which schemes they could potentially be looking at bidding against.
So because they are third-party schemes, that is largely with the promoters. I'm not quite sure I understand the question, but in terms of assessing what we, working with the promoters, what we agree to be the right direction of the transport solution, that can either be really obvious, in which case we redirect them in terms of light rail, or it's working through exactly what that specification is, and that's assessed as part of the strategic outline business case. Does that answer that question?
Yeah, so some of these lines could be part of the national rail, the heavy rail network, and some there is a potential for a segregated solution.
Yeah.
Okay. Right, so we have 3 further minutes. I'm going to bring the session to a close and brief what's about to happen with the informal networking. So in your invite to the session today, you'll have received a Zoom link. One of my colleagues will go and open that room now, so you'll be able to enter Zoom. After we enter Zoom, we're going to break out into individual rooms, and each of the speakers will be present in one of the rooms. So you'll be able to choose a room and pop into that room and network with your chosen speaker. And there'll be RIA reps moving around, facilitating the discussion as well. And I've got a copy of the remaining questions here. So I'll take those questions with me, and perhaps we'll have time to ask a few more of them slightly more informally. So if one of my colleagues can, Mel has just posted in the chat the Zoom link right there, so it's available to everybody. So you are now free to leave. I'd like to thank all of our speakers today and the time they've put into what's been a very informative afternoon. And I will see you all in 2 minutes on the other side. Okay. Bye-bye.
James? Are you having trouble finding the link? You're muted.
I think I've cracked it.
Okay, yeah. You can open Zoom just before you close GoToWebinar, but I think any minute now, Milder will probably close GoToWebinar anyway. But if you paste it into a browser, you should be good to go.
All right, lovely. I think I've got it working.
All right,
Cheers.
super. See you on the other side.
Yep.
I'll
Cheers.
just wait for people to leave and then I'll close the GoTo, but the Zoom is open now, so I will not be able to open the rooms before I close this GoToWebinar
Right.
meeting.
How do you actually close the GoToWebinar meeting, Milder? You
You click on the X.
Ah, right, that's as simple as that. Okay, right, I'm closing it. See you soon.
I will close the webinar now. Just to repeat, you can find the link in the reminder email that you received an hour before this webinar. And if you can't find the email, it might be in your junk mail and it would have come directly from GoToWebinar. If not, just drop me an email. Again, you find my email in any of the emails that came about this event. So just drop me an email and I will send you the link. I am closing the webinar now.